Welcome to our review of the properties of the derivative of a vector-valued functions, part 1. In this video we'll take a look at proving the property involving the derivative of a dot product. So here are the 6 properties of the derivative of a vector-valued function we're going to take a look at. These will look very familiar to some of the properties that we reviewed when we were finding derivatives of basic functions. This first property just states that if we want to find the derivative of a constant times a vector-valued function r of t, that'll just equal the constant times the derivative of that vector-valued function. The second property just states that if we have a sum or difference of vector-valued functions and we want to find the derivative of them, we just find the derivative of each vector-valued function individually. This third property states if we have a function in terms of t times a vector-valued function, it's going to equal the function in terms of t times the derivative of the vector-valued function plus the derivative of the function times the vector-valued function r of t. This should remind you of the product rule, but in this case keep in mind that f of t is a function in terms of t and r of t is a vector-valued function. Number 4 is the property we're going to prove in this video. It says the derivative of the dot product of two vectors is equal to the first vector-valued function dotted with the derivative of the second plus the derivative of the first vector-valued function dotted with the second. And then the fifth property states if we want to find the derivative of the cross product of two vector-valued functions, it's going to be equal to the first vector-valued function crossed with the derivative of the second plus the derivative of the first vector-valued function crossed with the second vector-valued function. Again, this looks very similar to the product rule, but now we are talking about cross products. And this sixth property will remind you of the chain rule when finding derivatives. Okay, but for this video we're going to take a look at proving property number 4. In part 2 of this video we'll take a look at verifying property number 5. So let's see if we can prove this. Again, we want to show that the derivative of the dot product of these two vectors with respect to t is equal to the first vector-valued function dotted with the derivative of the second plus the derivative of the first vector-valued function dotted with the second. Let's start by defining r of t and u of t. To save a little bit of work, we'll define these two vectors as only having the x and y components. So we'll call this x sub 1 of t comma y sub 1 of t, and then we'll let the vector-valued function u equal x sub 2 of t and y sub 2 of t. And to prove this, we are going to have to know the derivatives of these vector-valued functions. So let's go ahead and list those as well. The derivative of the vector-valued function r is going to be equal to x sub 1 prime of t and y sub 1 prime of t. And so u prime is going to be equal to x sub 2 prime of t and y sub 2 prime of t. So we'll start with the left side and see if we can come up with the right side of this property. This is going to be equal to the derivative with respect to t of the dot product of r and u. So we would have x sub 1 of t times x sub 2 of t. Remember, this is dot product here, this is multiplication here, plus y sub 1 of t times y sub 2 of t. So now to find the derivative of these two products, we'll have to apply the product rule here and the product rule here as well. Remember, the product rule says we're going to take the first function, x sub 1 of t, multiply it by the derivative of the second, x sub 2 prime of t, plus the derivative of the first, x sub 1 prime of t times the second, x sub 2 of t. So all of this is just the derivative of this first product, and now we'll find the derivative of this product. So we're going to have plus the same product rule, so we'll have y sub 1 of t times y sub 2 prime of t plus y sub 1 prime of t times y sub 2 of t. Again, this is the derivative of the y part applying the product rule. So believe it or not, the only thing left to do now is to reorder these products, meaning we're going to go ahead and leave this in the first position. We'll move this product into the second position, move this into the third position, move this into the fourth position. If we take a look at the sum of these first two products, x sub 1 of t times x sub 2 prime of t would be the x component of r times the x component of u prime, and then y1 of t times y2 prime of t would be the y component of r times the y component of u prime. So this is equal to r of t dotted with u prime of t. If we take a look at the sum of these last two products, x sub 1 prime of t times x sub 2 of t is the x component of r prime times the x component of u, and y sub 1 prime of t times y sub 2 of t is the y component of r prime times the y component of u. So that gives us what we want. This is r prime of t dotted with u of t. So there's the proof of property 4. In the next video we'll take a look at not proving but verifying property 5. Thank you for watching.